Let's go to page 115 and number 131. So you have a f of x is equal to square root of 2x plus 5 minus square root of x plus 7 over x minus 2, and this is for x not equal to 2 and equal to k for x equal to 2. So you're looking for the value of k so that this will be continuous at x equal to 2. Now in order for this to be continuous, the limit when x approach to 2 will equal to x equal to 2. So they have to be equal to each other. So to find this, you need to find the limit of this approach to 2. Okay. So you need to find out what this is equal to, and it will be the value of k. Okay. So you want to find out the value of these so that k will have to equal the same value to be continuous. Okay, so now you cannot substitute it in the 2 directly, so you need to multiply by conjugate. Okay. So do not multiply the bottom, keep the bottom the same. Okay, now the top, when you multiply the conjugate, you just multiply the corresponding part. So this will give you 2x plus 5. This will give you minus. Now you have to minus everything inside, so it will be minus x minus 7. Okay. So on the top, you're going to get x minus 2. On the bottom, you're going to get x minus 2. Again, that's the reason for conjugate, so it will cancel out. So this cancel out. So this will equal to the limit of x approach to 2 over 1 over square root of 2x plus 5 plus square root of x plus 7. Okay, so now you can go and substitute this in directly. So this will equal to, so once you substitute, you can get rid of the limit. So this is equal to 1 over square root of 9, and this will also plus square root of 9. So this will equal to 1 over 3 plus 3. So this is equal to 1 over 6. Okay. So the limit will approach 1 over 6. Therefore, k have to be equal to 1 over 6 to be continuous. Okay. Okay, so page 116, number 132i, you're looking for the limit of sine of 3x over 6x as x approach to infinity. Yeah. Okay. So if you notice, when x approach infinity, there's no bound. This is not bounded, so this is going to become infinity. And sine of 3x is going to go up and down, up and down. It's going to be between -1 and 1. So therefore, this is going to be equal to 0. Okay. Okay, so 132ii, looking for the limit of x approach to -2 of x to the 3 plus 8 over x plus 2. Okay, so you can first check if you can substitute directly. In this case, you cannot. So let's go and do the factoring to cancel. So this is going to be x plus 2, and be x squared minus 2x plus 4 over x plus 2. And this will cancel out. Now once it cancel out, then you can substitute. So this becomes -2 squared minus 2 times -2 plus 4. And so this will equal to 4 plus 4 plus 4, so equal to 12. Okay. Okay, let's go to the next one. So 132 triple I. So you have the limit of x approach to 16 of square root of x minus 4 over x minus 16. So again, first you check see if you can substitute directly. In this case, you cannot. So go ahead and multiply by the conjugate. Usually when you see square root, that's your clue that you have to multiply by conjugate. So it'd be square root of x plus 4, square root of x plus 4. So again, so on the bottom, do not multiply out the bottom. You just keep it in the square root, in the parentheses. So over here, you multiply, so this would be x minus 16. And again, this will cancel out. So this becomes the limit of 1 over square root of x plus 4. So now you can substitute. So this will equal to 1 over square root of 16 plus 4. So this is equal to 1 over 8. Okay, let's go to number 133. Okay, so you have a f of x is equal to x squared minus x minus 2 over x plus 2. And this one has an oblique or Sine Asymptote. So you want to find the equation of Slant Asymptote. Okay, so to do that, you just going to do the long division. So there will be x, so multiply, so you're going to get x squared plus 2x. Draw the line, put parentheses, subtract. So this cancel out. So negative 1 minus 2 will give you negative 3. Okay, and then you drop. So this would be minus 3. So it would be minus 3x minus 6. By the way, once you get over here, you don't even have to do this. Okay, this is only when you want to find the entire equation. But this will be your asymptote already. Okay, so minus, so this becomes 4. Okay, so so this equation will equal to x minus 3 plus 4 over x plus 2. Okay, so this is the entire graph, but the part of your quotient is your asymptote. Okay, so again, so your slant asymptote would be y equal to x minus 3. So your quotient is your asymptote. Okay, let's go to the next one. Okay, so you want to evaluate the limit of square root of 4x squared plus 5x minus square root of 4x squared plus x. Okay, so again, first, if you were to substitute, then this is going to be bad. Okay, so what you want to do is, again, when you have a square root, okay, let's go and multiply by conjugate. So put this over 1, and you multiply by the conjugate. So it would be square root of 4x squared plus 5x plus square root of 4x squared plus x. Okay, so multiply by conjugate. Okay, so this will equal to the limit of so let's go and multiply these things out. So this multiply will give you 4x squared plus 5x, and so this will be so you have to multiply this would be minus this whole thing, so it would be minus 4x squared minus x. Okay. And on the bottom, you're going to get square root of 4x squared plus 5x plus square root of 4x squared plus x. Okay, so this will equal to the limit of, so this will all cancel, so you're going to get 4x on the top, okay? And on the bottom, I'm going to factor out the x squared, okay? so I'm going to do this, x squared, and I'm going to get 4 plus 5 over x. Okay, again, I'm going to factor out the x squared. So you're going to get 4 plus 1 over x. And then this will come out. Oh, this is the plus. Okay. So you're going to get 4x. So this comes out, so you're going to be x square root of 4 plus 5 over x plus x square root of 4 plus 1 over x. Okay, and so this will equal to, well, the x will cancel out. So this would be, you factor the x. Okay, so you factor the x. Okay, let's do one more step. So it will be a 4x, and over here I'm going to factor the x. So you're going to get square root of 4 plus 5 over x plus square root of 4 plus 1 over x. Okay, so the x will cancel out. So this will equal to the limit of 1 over square root of 4 plus 5 over x plus square root of 4 plus 1 over x. Okay, so now when x is approaching infinity, this is going to give you 0, right? So again, x approaching infinity is going to become 0. So this is going to equal to 1 over square root of 4 plus square root of 4. So this is equal to 1 over 2 plus 2. Oh, wait, this is a 4. There you go. Okay, so this will equal to 1. Okay. Okay, let's go to the next one. Okay, 135. You want to evaluate the limit of sine squared x over x as x approach to 0. Okay, so we can break this up. So this is equal to the limit of sine x over x, limit of sine x, x approach to 0. Okay, so you can break this up into this so that we can evaluate each one. So this one is equal to 1, this one is equal to 0, and so ends will equal to 0. Okay, let's go to next one. Okay, so this one you want to evaluate the limit of theta, cotangent theta, as theta approaches to 0. Okay, so again, let's go and break these things up. So this will equal to the limit of theta approach to 0. So we're going to, so cotangent is cosine over sine, so we're going to do this. Okay. Right, cotangent is cosine over sine. And so we can break these things up. So this is equal to the, so we can do each one individually. Okay. So remember, this is a reciprocal of 1. Okay. So this is going to be, this is same as 1 over the limit of sine theta over theta. Okay, that's that. Okay. Okay, so therefore this would be equal to 1 over 1. Okay, and cosine theta as, so this one you can substitute directly. Right, so cosine of 0. Right, again, if you can substitute directly, you can do that. So cosine of 0 is equal to 1. and so this will equal to 1. Okay, let's go to the next one. Okay, so you want to do this proof, so you can start with this one here. So you start with this one, and you can use that identity to prove that this is equal to 0. Okay. So you can apply the identity to this, so this becomes the limit of sine square x over x times 1 plus cosine of x. Okay, so you want to use this identity to prove that this is equal to 0. Okay, so you're going to start to break things up. So first I'm going to have the sine x over x. Okay, so that's one part. And then I have this part over here. So I need to have a limit of sine x. Okay. So that takes care of this part of it. Then I have this part over here. Okay. So you can break the parts so that we can evaluate. Okay, this one we know that this is equal to 1. This one, so you can substitute directly. So sine of 0 is equal to 0. And this one over here, so you can substitute cosine of 0 is 1. So this is 1 over 1 plus 1. Okay? But anytime we times 0 is equal to 0, so this will equal to 0. Okay. And that's it. Okay, let's go to the next one. Okay, find all the asymptote of the function. So you got f of x equal to x cubed over x squared minus 1. So you're looking for all the asymptotes. Okay, so first let's go and do all the factoring. So you got x cubed, and you're going to have an x plus 1, x minus 1. Okay. So right away from here, you're going to have the vertical asymptote. It's going to be at x equal to -1, x equal to 1. Okay. The next is that the degree on the top is bigger than the bottom, so you're going to get slant asymptote. So to find the slant asymptote, you have to divide. So you got x cubed divided by x squared minus 1. So this would be x, so it would be x squared minus x, x cubed minus x. So you subtract. So this would become x. So your equation, so your f of x is equal to x plus x over x squared minus 1. Okay, so this is the whole equation. But the asymptote, the slant asymptote would be this part over here. Okay, so in this case, you're going to get the slant asymptote would be y equal to x. So here are your 3 asymptotes. Okay, okay, let's go to the next one. Okay, so you have to evaluate the limit. So limit x approach to infinity. So you got 6x over square root of 9x squared plus 17x. Okay. So this one you cannot really substitute directly. So what you need to do is you want to go and take out the perfect square. So you're going to factor out the 9x squared. So factor out the 9x squared so that you get 1 plus 17x over 9x squared. Okay, and then you can simplify after that. So this will equal to 6x. So this one can take out, so you get 3x, and you're going to get 1. Wait, this is the square root of. So this comes out, so So you get square root of 1 plus the x cancels would be 17 over 9x. Okay, so now you can go and cancel. So this cancel with this, so you get 2 over square root of 1 plus 17 over 9x. Okay, so now you can substitute. When x approaches infinity, this is going to become 0. So you're going to get equal to 2 over square root of 1, and therefore the answer would be equal to 2. Okay, let's go to the next one. Okay, so you want to evaluate the limit of square root of 3x squared plus 17x over x as x approaches to infinity. Okay, so again, first you need to go and factor out this over here. Okay. So this will equal to, so basically whatever the leading term is, you want to go and factor it out. Okay, so whatever the leading term is, you're going to factor it out, and you're going to get that. Okay, now you're going to take these things out. So you're going to get square root of 3x times square root of 1 plus 17 over 3x over x. Okay, so now the x will cancel out. So you get limit of x approaching infinity of square root of 3 times 1 plus 17 over 3x over 1. So now when x approaches infinity, this is going to become 0. Okay? So you end up with square root of 3 times square root of 1. So this will equal to square root of 3.